Something is seriously wrong with our understanding of the universe, according to what the James Webb telescope confirms. Depending on where we look, the universe is expanding at different rates. Now, scientists using the James Webb and Hubble space telescopes have confirmed that the observation is not down to the measurement error. Astronomers have used the James Webb and Hubble space telescopes to confirm one of the most troubling conundrums in all of physics, that the universe appears to be expanding at baffling different rates depending on where we look. This problem, known as the Hubble tension, has the potential to alter or even upend cosmology altogether. In 2019, measurements by the Hubble Space Telescope confirmed the puzzle was real. In 2023, even more precise measurements from James Webb Space Telescope JWST cemented the discrepancy. And now a triple check by both telescopes working together appears to have put the possibility of any measurement error to bed for good. The study, published February 6 in the Astrophysical Journal Letters, suggests that there may be something seriously wrong with our understanding of the universe. With measurements errors negated, what remains is a real and exciting possibility. We have misunderstood the universe. Anyway, we had theories, they weren't proof, just theories. Lead study author Adam Rice, professor of physics and astronomy at Johns Hopkins University, said. Rice, Saul Perlmutter, and Brian Schmidt won the 2011 Nobel Prize in Physics for their 1998 discovery of dark energy, the mysterious force behind the universe's accelerated expansion. Currently, there are two gold standard methods for figuring out the Hubble constant, a value that describes the expansion rate of the universe. The first involves poring over the tiny fluctuations in the cosmic microwave background, CMB for short. An ancient relic of the universe's first light produced just 380,000 years ago, 330,000 years after the Big Bang. And between 2009 and 2013, astronomers mapped out this microwave fuzz using the European Space Agency's Planck satellite to infer a Hubble constant of roughly 46,200 miles per hour per million light years, or roughly 67 kilometers per second per megaparsec. The second method used pulsating stars called Cepheid variables. Cepheid stars are dying, and their outer layers of helium gas grow and shrink as they absorb and release the star's radiation, making them periodically flicker like distant signal lamps. As Cepheids get brighter, they pulsate more slowly, giving astronomers a means to measure their absolute brightness. By comparing this brightness to their observed brightness, astronomers can chain Cepheids into a cosmic distance ladder to peer even deeper, ever deeper into the universe's past. And with ladder in space in place, astronomers can find the precise number for its expansion from how the Cepheid's light has been stretched out or redshifted. But this is where the mystery begins. According to Cepheid variable measurements taken by Rice and his colleagues, the universe's expansion rate is around 74 kilometers per parsec, an impossibly high value when compared to Planck's measurements. Cosmology has been hurtled into uncharted territory. In other words, they claim that it's expanding twice as fast. Now, we would not call it a tension or problem, but rather a crisis. David Gross, Nobel Prize-winning astronomer, said at a 2019 conference at the Kavli Institute in California. Initially, some scientists thought that the disparity could be a result of the measurement error caused by the blending of Cepheids with other stars in Hubble's aperture, but in 2023, the researchers used a more accurate James Webb telescope to confirm that for the first rungs of the cosmic ladder, their Hubble measurements were right. Nevertheless, the possibility of crowding further back in the universe past remained. To resolve the issue, Rice and colleagues built on their previous measurements, observing 1,000 more Cepheid stars in 5 host galaxies as remote as 130 million light years from our Earth. After comparing their data to Hubble's, the astronomer confirmed their past measurements of the Hubble constant. We have now spanned the whole range of what Hubble observed, and we can rule out the measurement error as the cause of the Hubble tension with a very high confidence, Rice said. Combining Webb and Hubble gives us the best of both worlds. We find that the Hubble measurements remain reliable as we climb farther along in the cosmic distance ladder. In other words, the tension at the heart of cosmology is here to stay. And this is by Ben Turner on Life Science. Please leave your comments. Thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.